bases. Reactions of bases. Number 1, with metal. With metal, same like as salt, it is also reacting with the metal. For example, NaOH plus zinc, it forms salt plus H2 gas, same like as acid. Acid also, when they are reacting with the metals, they release H2 gas along with the formation of salt, even though it forms Na2ZnO2 plus H2 gas. And with acid, NaOH, already this example we already seen, and MgOH twice plus H2SO4 plus H2SO4. Here this is a neutralization reaction. We already discussed how the neutralization takes place. Here I am going to explain. H2SO4 is releasing 2 H plus ions and MgOH twice is releasing 2 OH minus ions. These 2 OH and 2 H plus ions react together. They are forming 2 molecules of H2. What is the remaining? Magnesium sulfate. Magnesium sulfate. If we are taking MgOH twice with HCl, HCl is able to release only 1 H plus ion, so that we want to take 2 HCl molecules, then it releases 2 H plus, here 2 OH minus, they react together, they are forming 2 molecules of H2O and MgCl2. This is a neutralization, means OH minus ions are reacting with H plus ions. They are converting into the water. This water is not an acid, not a base. So that is called as a neutralization reaction. After that, reaction with heavy metal salt. Heavy metal salts. For example, ZnSO4 plus NaOH. ZnSO4 plus NaOH, it undergoes Na2SO4 and ZnOH twice. Zn, double displacement reaction takes place. Double displacement reaction takes place. After that, reaction with non-metallic oxides. Why we are taking metallic oxides for acid, non-metallic oxides for base? Because these non-metallic oxides are acidic in nature. Metallic oxides are basic in nature. So which are basic, they will react with acid. Which are acidic, they will react with the base. So for example, CO2, when reacts with NaOH, it forms Na2CO3. It forms Na2CO3 plus H2. So salt plus water, just like as a neutralization reaction. Salt plus water, just like as a neutralization. If even though ammonia is not an arrhenius base, but it is having the basic nature. Ammonia also one of the example for base, and not what is the definition we learned. It is a base based on Lewis theory. theory. So this is called as a Lewis base. This is called as a Lewis base. What is Lewis base means? Here one lone pair of electron will be there on ammonia. Ammonia is able to donate this lone pair of electron. Who are donating the lone pair of electron? That is called as a Lewis base. That is the definition. Okay. Now this base when reacts with water, here there is no OH minus ions to lose in the water. So what is going to be happen? Water means one H plus ion and one OH minus ion. H plus ion is adding to the ammonia, means NH4 plus H2. Sorry, OH minus. OH minus. Okay, here ammonia also base. Which base? Lewis base. Lewis base when undergoes reaction with water, it gains the H plus ions from water. Right. Characteristics of bases. Bases are bitter in taste. Acids are sour in taste, bitter in taste, and turns the red litmus to blue. There blue litmus to red, here red litmus to blue, and does not conduct the electricity. Does not conduct electricity. Does not conduct electricity. These are the characteristics of base. Now, how to identify? Both are colorless. Some acids are colorless, some bases are colorless. How to identify whether it is an acid or a base or water? Water also colorless, acid also colorless, base also colorless. How can we identify whether it is acid, base or water? By using indicators. By using indicators. So now we are going to discuss about indicators. What is meant by indicator? It is using to identify. To identify the acid and base. Acid and base. How can we identify? By changing of color. By changing of color. By changing of color. How many types of indicators are there? Two types of indicators are there. One is natural indicators. Another one is artificial, means synthetic indicators. They are synthetic. They are preparing in lab. Synthetic indicators. And third one also comes under to the natural only, but and olfactory indicators. Olfactory indicators also comes under to the natural only, because why we are separating? This is based on smell. Based on smell. If you take natural indicators and synthetic indicators based on changing of color, but it is based on smell. What are natural indicators? Right. Indicators, natural indicator. First one, natural indicator. Number one, litmus. Litmus is a natural indicator. Actual color is, it is coming from the essential of flowers. That is, actual color is purple color. Actual color of litmus is purple. We are converting into two colors. One is a blue litmus, another one is red litmus. These are available even in our laboratory also. Blue litmus paper, red litmus paper. Blue litmus paper with acid and base. What is the color change? Acid converts the blue litmus to red, but base no effect means no change on blue color. Means blue color is remains like that only. But in case of acid and base, in case of red litmus, acid remains the red color like that only. There is no change. In case of base turns the red litmus to blue color. Red litmus to blue color. So this is a litmus test. This test is called as litmus test. Generally we are using in our laboratory. So this litmus also comes under to the natural indicator. After that, second one in natural indicators, turmeric powder. Generally we are using in our regular life, turmeric powder with acid and base. Turmeric powder, even though we are getting cold, generally we are getting cold, and that time we are taking the turmeric milk, yellow milk generally we are taking. What we are doing on that time, we are adding some turmeric powder to the milk and heating by taking. So what is the color of that milk? By adding the turmeric powder, what is the color? Yellow color only. Means there is no change. Milk contains acid. So if we are adding the turmeric powder to the acid, no change in the color with acid. No change in color of turmeric powder. Means yellow color only. Yellow color. Right. If we are applying the turmeric paste to our hands and wash it with soap. Soap contains base and that yellow color turns to red. So with the base, turmeric yellow turns to red. This generally we are using in our. After that, third one, red cabbage. Red cabbage is actually purple in color. This is with acid, purple turns to red. With base, purple turns to green. So these three are natural indicators what we are using in our regular life. After that, olfactory indicators. I already told you olfactory indicators are based on smell. For example, onion, clove oil, and vanilla essence. All these are having some smell. All these substances are having some smell. If we are adding acid and a base, the smell will be remains for onion and clove oil and vanilla essence. Smell does not disappears. If you want to check, take onion and rub on your hands and wash it with milk. That smell will be remains. Means there is no disappearance of its smell. base, if you can wash it with the soap, the smell will be disappears. Smell disappears. Smell disappears. So then we can find out that is acid or base. For these three are having a good smell. If the smell is not disappearing, that is acid. If smell disappears, that is base. After that, synthetic indicators. After that, synthetic indicators. This is what we are using in our laboratory and preparing in our laboratory. Both are using and preparation, both are in laboratory. For that, phenolphthalein and one is phenolphthalein indicator, which is colorless. After that, methyl orange. Which is orange color. If we are adding to the acid and base, phenolphthalein is colorless, so with acid also it is colorless. And methyl orange is orange color, but with acid it is red. It turns to red. With base, phenolphthalein indicator turns to pink color. And methyl orange indicator turns to yellow color. Means orange color turns to yellow color. Orange color turns to red in case of acid. Colorless, let it be as a colorless in case of acid. If it is turns to pink color, that is base. These are we are generally using in our laboratory. After that, one more, these two are synthetic indicators. Phenolphthalein indicator and methyl orange indicator, two are synthetic. One more synthetic indicator is there, that is pH paper. Actually, based on pH, we have much explanation, but pH paper is we are using as an indicator. What is a pH, that we are discussing after in next class. But pH paper is we are as an indicator we are using in our laboratory. That is yellow color paper. Yellow strips are there, like as a litmus paper. How the litmus, blue litmus, red litmus strips are there, like that yellow color strips will be available in our laboratory with acid and base. Acid, if yellow color changes to red color or orange color, that is an acid. If it turns to which one? pH paper, yellow color turns to blue or pale blue, that is base. If it is a neutral, means like as water, neutral, pH turns to yellow color turns to green color. So this is also we are using as an indicator in our laboratory. Okay.